Right, it's Gadget UK here again, just looking at this GVP accelerator board here. This was donated by Tom in a previous video actually. Now, my first thoughts with this when I saw this is, oh no, look at all these PALs here, you know, trying to get the JEDEC code for these can be a pain. But, yeah, I quickly inspected the board. You can see I fixed a trace, sorry, we're not on camera, are we? Fixed a trace here. There was, you know, it's had an impact there and there was a break. So I fixed that, still the same. What happens with this, it gives a black screen and after about 10 seconds the floppy drive lights as if it's actually booting, but then it just, that's it does no more. And I've done a number of things. I went to a website, I'll post a link down below. I think it's the Amiga Big Book of Hardware or something, just to check the jumpers, and I've changed the jumpers a few times. I think the way they configure at the moment is to set this at 25 megahertz. You can see it's got an MC68030 RP on here. Is that the one with the MU? I think it might be. Anyway, I've set the jumpers so that it should be 25 megahertz. Now there is a crystal there, and the crystal, I think, the way the jumpers are configured is to provide clock to this 25 megahertz again. I tried without that, just the same. I tried a different CPU, just the same. Played with the jumpers a bit, you know, set them to 40 megahertz, just the same, set them to 50, just the same, set them back to 25, and getting nowhere with it. Inspected everything, can't really see anything, and I was about to contemplate, well, a few things. One thing I thought I had was, I wonder if it's done the auto config bit, added the RAM, and then this then becomes the default RAM that it's using. I don't think so, because it's going to be Zorro 2, so it's going to use the chip RAM on the board, I would think, rather than this, when in terms of the boot up. But that was one thought. I've got some of these spare, so I could swap some of those out. My other thought was divide and conquer. I've got some 245s here. I'm guessing that ROM is isolated by the 245s. So if we had a fault there, it might be killing the data bus or something. And we've got some 245s here, but this might be related to the SCSI stuff, because one or two of the connections seem to go there. There's some 7474s here, quite a lot of them. Those I know are notorious for failing on certain boards. And it's all generally, because those are like a flip-flop, they'll be to do with clock stuff. So I thought, well, actually, we've got nothing to lose. We could swap out all the 7474s there. We could swap these 245s around, you know, try them without them, etc. But then inspecting again here, something was niggling in the back of my mind, thinking, let's look at this again. I've looked everywhere else, and I spotted it's actually a 4-layer board. Can you see the black traces running through there? So the damage here is damaging those 2 or 3 traces there as well. I think that might be it. That might be what's wrong with this. So somehow I've got to work out where these go. Now you can follow them along here, and then that's it. You can't see them then because they're under here. So I don't know where they go. I could use some ultra powerful light, try and shine through the board, see if I can see any traces coming down, but there's no guarantee it's those, you know, something else from down on another layer here. You know, you can see the black traces here, could be going there, so yeah, quite problematic. And what I can do is just try and shave the surface of this down here, see if we can get to these, to expose them. I don't know if they're going to be able to solder anything on there or what. I don't know how thick the copper is on the inner layers on something like this, and see if we can bridge them here. So I think that's what I'm going to try next. Nothing to lose. We can see where they go here. You know, there's a via one goes somewhere, I can't see where, but certainly 2 of them. Mind you, it's that outer one that's likely to be the most likely to have broken. But anyway, I think that's what it is. So I'm going to try and I don't know, scrape away at this area a little bit.
So as you can tell from the start of the video there, that was back on the carpet in the conservatory. So we've now moved obviously to this new environment. So I've cut quite a lot out of this video. I spent ages working on this card. There's lots of chip removals and swapping around for new components and things that, yeah, I've cut out, as you'll see later on in the video. But the trace there on the SCSI card, I'll show you that in a second up close. I was able to just like scratch the surface with a fiberglass pen and my scratchy tool really, really carefully for, I don't know, 10 minutes or so, and actually get through to the layer below. So I was able to see that, and it was, even though it looked black, once you got to those you could actually solder onto them with a conductive. It's like a silver type of surface. So I was able to patch up the 1 or 2 there, and you'll see that later in the video. But after doing that and getting nowhere, still didn't make any difference. I thought, well, it's not an Occam's razor. It's not the simplest explanation, you know, i.e. some board damage on the edge. That seems to be unrelated. It's a reset issue. So I was like logic probing the 68K CPU socket there, There's pin 18 is the reset, and it's stuck low all the time. And now I did notice initially when it was really warm in the conservatory, it would occasionally come out of reset, and I think I might mention that in a minute actually, that you know, I noticed this reset problem, but it seemed to be temperature related. But the next few clips you'll see me looking at the reset side of things, but then ultimately just having a step back and actually looking at the clock stuff. You know, when you're trying to diagnose something like this, you should obviously do the basic things like check your power, check your clocks, check your reset, etc. Now the clock stuff, I think I tested early on and I measured clocks and things in the correct places there, but there was a question in my mind is a symptom versus cause. So what I mean is sometimes you can think you've got a problem with reset like we have on this board now, where it's not coming out of reset, and you can be looking at the reset, nothing but the reset, and actually it's not the reset. It could be some address decoding somewhere, it could be a clock problem, i.e. you know, the combinational logic within the Mac chip or a GAL or something. Well, PAL actually, PAL chips on there, one of those chips that does that decoding, if it's missing a clock somewhere, that would be enough to not come out of reset. So there's a lot of sidestepping, as you'll see, and there's lots and lots of stuff I've removed from this just based on the fact it's been a really complicated thing to diagnose.
So I don't think this will fix it. I've just removed that with hot air, 415 degrees for about a minute, I would say. Got some flux on there. Just going to clean up the pads here, just get rid of the solder off them. Now I've not got an A 74A 74. I've got a 74 LS, I think. I'm going to give that a try. I could always order one if this shows any signs of behaviour, you know, different behaviour. But I was probing around, just following the reset signal there. I think this is a decoder chip here, but it connects to the 7474, and I was looking at the input pins on that 7474. On the data pin, the clock pin, I see a pulse, and I see a high on the data pin. I think the other two pins are in the correct state, so that the output should be pulsing, I think, and it isn't doing. It's just doing nothing. So, well, it's at low. So yeah, I'm going to try in this 7474. Let me just make sure I get this the right way around. I mean, the worst that could happen is it's exactly the same, and if that's the case, I will at some point swap back to the old chip. But we've got nothing to lose by trying this, I guess. I mean, the thing is, you know, you can get symptoms and you can get causes, and the whole thing with it not coming out of reset could be something else, you know. It might not just necessarily be the reset pulse. There could be something else it's waiting for. For example, on a board like this, there might be a time delay there when it first powers on in order to give the SCSI time to come up, you know. It might be waiting for the SCSI, so even change this, it might not make a difference. I might be mistaken in terms of, you know, me thinking should be some pulsing going on when there shouldn't, you know. I don't know. Maybe we'll just get a bit of solder on there. Yeah. Got way too much solder there actually, because I'm going to start bridging them all now. Use a bit of flux to get that off there. Yeah, that side's not too bad. Can you see that? No bridges. Anyway, it's nice and easy to check that. Just clean that off and we'll go test it again. So there is definitely a problem with this card not coming out of reset. But I just, you know, spent some time retesting again and feeling the temperature of various things, and it's like stone cold, you know. Some of these are a bit warm, just lightly warm. These are all stone cold here. These are hot, but not boiling hot. But the one thing I did find, these 74AS646s here are red hot. They get baking hot just after a few seconds, which I find a little bit odd actually, especially considering it's not even come out of reset. So I've taken a punt, so I've ordered some replacement chips there, and we'll just swap them out anyway. We'll just see, you know, it's a stab in the dark, but we'll just see if that makes any difference, because these are the hottest things on the board, and I would actually expect these to be hotter, because these tend to get hot, these PAL chips here. Anyway, let's get them both off, and I'll replace them and we'll retest it. I'm not expecting it to make any difference, if I'm honest. It is just guesswork here, because there's a lot I don't know or understand about how these cards work, and even how a 68030 sits on the Amiga system there, you know, in terms of how it drives all the signals and responds and all the rest of it, because there's a hell of a lot of pins. Yeah, I can see it moving now. It's lifting on one side. So we'll just heat that side, then we'll go back to this side. There you go, I can see all the solder changing colour on that side. There we go, the chip off. You can see some funny colours on the wires there. That might just be a consequence of heating. And the reason I'm thinking it might not be these is if something's wrong with the way that this card's working, like in terms of address decoding, you know, things enabled or disabled at the wrong point, these chips could well get hot because they're kind of like enabled when they shouldn't be or something like that. Does that make sense? You know, a fault somewhere else could create a bus conflict somewhere. And when you get a bus conflict where, you know, a chip like this maybe is set to output on its pins, and it should be set to input. You've got signals coming in, you know, and you've got a collision there, haven't you? You've got it trying to drive an output when it should be reading an input. Now that was coming off super easy. Came off easier than the other one actually. Quite surprised how easy that one came off. So again, the wires look really weird colours underneath, but is that a consequence of heating? I'm not sure. There's like a weird silhouette around each of them. So yeah, that's something I've never seen. Anyway, we've got a bit of flux onto the pad here. Let's just gently, carefully remove the solder. So I've got my fan there from ZXKim81 on Twitter. Fantastic, thanks for that, Kim. It's just going to help extract the fumes here while I work on these pads. So I've got a bit of flux, and we'll just suck up the solder there. Hopefully won't lose any pads. Yeah, those weird marks that were there, they've come off with a little bit of a clean look. It's very strange. Could just be dirt that's got on there, but it's really mysterious to get underneath it like that. So we'll get a little bit of solder onto the pad and hopefully try and flow it, there you go, onto the pin. Do the same thing over here. There you go. Just press it down and reflow. That's it, I'm not bothered about that bridge. Yeah, that's nice and straight. I haven't really got the right tip for this, so I might have to bob in and out a little bit. Normally you just drag right across there like that. We can try that and see what happens. And we'll do the same here. I'm starting from the pin that's not secured there. Yeah, you can see it needs a bit more solder there. That's not bad actually. So I just need to remove that bridge there, and it's a bit the other side. So a bit of a random direction change. I came back to check it around here, and if I just take the crystal out. So I did try a few of the crystals. I tried a 40 and I tried 10. I don't think 10's fast enough, to be honest, but I didn't see any change in behaviour, so I don't think the crystal's the issue. I think that 04 has possibly died. That's probably what it is. Now I've got some HC04s here. Now it's an AS04, but I don't think that's going to make much difference. It might do by the time you get a 50 megahertz crystal on there, but for the 25 or slower, I think we'll be alright. So anyway, I'm going to free this up. I think it's just one chip in here actually. I think I originally ordered 2 of these. There we go. So we'll remove that and we'll fit that and see if that makes any difference. So as you can see, got some Captain tape around the plasticky bits around here for the PGA socket here and the crystal socket. It's not going to take much to get this off, I don't think, because it's a super small IC. The good news is the 2 ICs are replaced. They're cold now. You know, barely lukewarm. Those other ones were getting super hot. So maybe there were 2 issues with this. It might just be the way those other chips were. You know, I've had chips get hot on boards before and there's actually nothing wrong with them. So anyway, we'll soon find out. Let's get this off here. It'd be amazing if this sprung back to life. It really would, because I think you can run these at 50 megahertz, these boards. not putting any pressure on it here, and it's going at a weird angle. Let's come off there. Look. Yeah, there we go. So again, weird coloured discoloration on the via there. So part of me thinks there is no chance this is going to fix it, but the optimistic part of my brain is going, well, hang on a minute, it's an inverter and we're not seeing it inverting. So maybe it really is this simple. What I haven't done is scope the clock signal there. That's the next thing. I'm just being a bit lazy because my hammock, it's in another room and it's like under a table and it's a big bulky thing, and I just got nowhere to leave it set out, to leave it set up. So yeah, it comes out when I absolutely, desperately need to resort to using it, but yeah, we might be at that point if this doesn't shed any light on it. It is a bit strange though that there's no clock, at all. There's nothing really to show you, it's just like no inversion going on whatsoever. So let's get the 74HC04 on. If this works, then I will order an AS04 before I try, clocking this up to 50 MHz. I mean, I could try it at 50 MHz with a HC chip, but I think the AS is going to be better. The AS is advanced Schottky. So the clock stuff here I think was a red herring because I scoped it, and anyway, it seems alright. So I've put the original chip back on, but in the meantime I thought I'll reset the CPU again. And you know what, under closer inspection, I don't know whether you're going to be able to see here, might have to put you on macro. Some of the, just ignore the fluff on the end of there, some of the pin things on here are totally bent, like really, really badly. You're not going to be able to see it because the holes are so small, but I can see several of them where I would imagine it'd be very hard for the pin on the CPU to make a connection actually. So I'm not sure if that, I don't think that's going to be the fault, but we've got to rule it out maybe, so I might have to replace this, I think. So looking through my sockets here, I think I have some. That one's for an 020. These I think are for an 030. It looks that way. And if we just compare the profile here, I managed to manipulate this a little bit. I'm not sure which way around it goes. Is it that way? Yeah, I think it's that way, isn't it? Yeah, that seems to marry up. So yeah, I could remove this and get a new socket on. I'll put you on macro. This, the pins are very, very mangled. I could imagine 3 or 4 or 5, maybe several pins not making a connection there. So maybe this is why this isn't coming out of reset. And it's the same with this. So I mean, if it did spring to life after replacing that, I would need to replace this socket as well, actually. I'd probably fit a crystal socket while I'm at it as well, and maybe even replace that one because it's not that clever. So you're on macro. If I just rotate around this, just look into the holes if you can see. I mean, look at this one here just near the end. Look at this one and that one there. Look, it's awful. That one's well bent out of position. Now, I think before I replace the socket entirely, and look at some of these down here. Again, they're incredibly bent around and stuff and widened. Someone's forced the CPU into this when the pins have been misaligned, and ultimately that's what's damaged the socket. Yeah, I don't know whether you can see because the light is kind of obscuring it. You've got to get it the right light to be able to see. But I mean, certainly that one, you can see what I'm talking about there. Look at that one. So I'm going to have a go at removing the socket actually. The socket might not be the problem. It could be that the socket has been damaged as a result of attempts to try different CPUs and things in it, because it wasn't working. But I want to rule it out. So there we go, socket off, no damage. Some of the pins just fell out. This just came off really easily, and 1 or 2 of the pins, as you can see here, were just still stuck in the board, and they just then came out, no worries at all. So I'll inspect that, but I was looking under magnification, I can see a couple of pins in there, in the holes. So I think someone's broke off the pins at some point in the past. Now, I don't think they would be able to short against each other here looking at this. Each one's in its own little channel. But I still think we need to rule it out because I'm not convinced every pin was making a proper connection. So anyway, we need to get this around the right way now. There we go. Sit it on there. So I mean, it's not as good quality as the original one, you could argue. But anyway, it'll do the job. So I'll just solder all the pins there we'll plug the processor in and go and give it a try. So what we do know is the pin up the top corner here, which is kind of stuck low all the time, goes through the 05, in fact it's high, and it goes through the 05 here, which results in a low, which gives us a reset, probably on the other side of this connector actually. So it's kind of stuck in reset. Now I've probed various things here, and I can't see any issues. These two chips we swapped out because they were really warm, and having swapped them out, actually they're not really warm now, so maybe there was an issue there. These 245s and these actually in general are easy to probe. You can probe the things here, and if the high impedance, which I think these are, shows kind of nothing crazy going on there, it can't be kind of causing a data bus conflict or something like that. But this definitely does not come out of reset. So my thoughts are kind of on this actually, since the reset signal comes here, maybe it's this. But I think this board is doing two things, because I see the reset signal comes out, I think, on one of the pins here, out of this chip, via this chip. So it goes from this chip into a gate on here and then out to the connector. But also, the reset signal also goes into another one of these here, comes across to here, and then I can't work out, I think the other one goes back to here on the other gate. So it's like there's two things going on. I think it's kind of like sampling the reset signal, but also providing a reset signal. And I guess that kind of makes sense, so that it can, it can reset, but then beyond the reset, maybe it can detect if, I don't know, you do a keyboard reset or something like that. I honestly don't know. But the reset signal is going to two different places, and I can't trace the second signal. I know one of them comes from here. I don't know where the other one is going. It wouldn't make sense to have it go into two different places if it wasn't utilised somewhere else. So, I measured connectivity on all these 7.4s here, looking at the clear signal in particular, like the reset. I couldn't see any issue. I used a logic probe on these 7.4 chips. There's two there, one there, one over here, I think, and then two on the right hand side of the board. So there's quite a lot of flip-flops on there. Now, only one of them has got like a clock and data signal, and that's pulsing on this, obviously on one of the two Q pins there, Q and inverse Q. The other two, they kind of just sort of sat there, and I don't know whether it's because it's not doing what it should be doing, enabling something else that then could, maybe allow it to come out of reset. So it's all just guesswork, and it's the same with these. These will get warm. I don't know. I have no idea what are they doing. I don't know. I mean, I could look at ultimately what pins they're going to on here, but that doesn't really help me understand exactly what they're doing. So, one of these could be the reason it's not coming out of reset. So, yeah, I don't know. Is it going to be a programmable part like this? In which case it's, it's knackered. I don't know. In the meantime, I've ordered some AS74s. I've only got 3 here, but I figure let's just have a go. Let's swap these 3 here and see what happens. I'll do them one at a time, starting at the top there, and we'll just see if it makes any difference. I've got nothing to lose, because this isn't a really nice card here, and I've spent a fair bit of time, fixing the connection there, swapping out those chips, dealing with the socket. The socket is awful. I'll show you though, that socket can be repaired, the original one. But yeah, we've got nothing to lose, so I'm just taking a punt with this, really. So, I don't know whether to get excited or not, probably not. Now, we swapped all the 7.4s, so the 7.4, 7.4, 7.4, I think that's a 7.4, 7.4, 7.4, AS 7.4, advanced shock key. Made no difference. We've already swapped the socket there, no difference. I've tried different crystals, even at crazy speeds like this, 16 megahertz, just to see if I can see any signs of life at all. It's just not coming out of reset. So the thing I just did, I went through every single jumper, changed it into its alternate position, checked the reset line, give it for 10 seconds or so, still stuck low, and then switch it off, change jumper back, and then try another jumper. So yeah, I've gone through every single jumper, just on the off chance that, I don't know, it's reading the jumper configurations wrong and going into some weird mode where it's not coming out of reset, but that didn't make any difference. My other thoughts were maybe there's a resistor or something feeding this, because this is cold, and this is where the reset signal comes out of. And inspection around the board, I can't believe I missed this. I have looked at this board so many times with a magnification, and just look here. You can see there is a resistor missing there, and actually there's just like little bits of solder on there that almost look like maybe at some point in the past it had a component there. I'm not 100% sure, but I don't see any of the points on the board that look like that. So that makes me wonder if there was a resistor on there and it's come off. So maybe this has not got something it needs in order to come out of reset. Maybe there's actually nothing wrong with this blooming thing, other than the missing resistor. So I'm just going to take a guess. I'm going to put, I think, a 1K resistor there. Yeah, we'll try a 1K resistor there and see what difference that makes. Yeah, so I don't know, inconclusive, because you can see the solder blobs kind of look like maybe there was nothing ever soldered on there. You know, it doesn't look anything like the profile of the other components there, unless it got really hot and fell off, I don't know. So whilst I think that board is not salvageable at all, if I'm honest, there are obviously parts we can use. So I thought I'd have a go at fixing this socket actually. So I could have done this in retrospect. Rather than putting the new one on there, I could have actually cleaned this one up and fitted the original one back on. So obviously you would need to remove the socket to do this, but can you see these pins here? That straight, that one's like crooked here. They should be totally straight next to each other. I'll just see if I can do this one on camera. I might have to do it off camera. Hang on. Yeah, you can see how bent they are there. It's a case of trying to grab one and just hold and twist it a little bit to straighten it up somewhat. Let's just see if I can do the other one. Yeah, my fingernails need cutting again. Anyway, I'll show you the result in a minute. That's a bit better. Yeah, you can see there, that's much better. They're much straighter now, look. There's still a slight twist in them, but that's much better. So the pins are super straight in that socket. Look at this. This is a pin off an old 68030 that broke off into the socket. It was wedged in there into one of the little holes for the socket pins there. Right, so this repair project stalled, I don't know, about 2 years ago, I think. I think Tom sent me this card to look at, and there's a donation sort of thing, but I'll return it to him if I can get it working if he wants it. I'd be happy to have it in my collection, but it's up to him really. He can have it back if I can get it working. So since then, in the last week, I was informed by Stefan, an amazing guy who's supposed to be no end. He sent me so many nice things, but yeah, Stefan pointed out the gals are available for this now. Someone has either reverse engineered it or got a copy of the card that's got them unprotected or something, I don't know. So I've been able to program up all the gals apart from, well, the PALs originally. We replaced them with gals. Yeah, the Jeds for those are available. As I say, I'll be a link down below perhaps. And the only one I've not done is the PLCC one. I'll show you that because that's soldered on. That still gets warm. The others don't now. Well, these chips previously, when you switched it on, they got warm. These don't. Gals run cooler than PALs. But that one is warmer than any of the others. So I'm hoping maybe it's that. But, you know, it could be the Mac chip up here. It could be the damage on the PCB where some of the layers inside are damaged and I can't see them and can get to them, you know, and there's no schematics. So anyway, simple stuff since I'm revisiting it. It's just the same after swapping out all those chips on the bottom there. I thought, let's just check this crystal because I can't see the prints on it. So I'm just going to probe the contacts on the back here. You've got ground, VCC, and I think the clock output is this top right one here. But if I show you the scope, and I'll try not to block it, I just want to make sure it is oscillating. You know, the crystal is working, and we are getting 25 megahertz because that's how I've got this configured at the moment. And if I scope that pin, hang on. Oh, it's not that one, it's the bottom one. Yeah, it's the bottom pin. I'll hold that on there, bang on 25 megahertz. So we do have a clock. Now I checked all this stuff previously, but as I say, it's been 2 years since I last worked on it. So the next thing I'm going to do is just have a look. My recollection was it was held in reset. So just looking at the 68,000 pin out there, reset is pin 18. And I believe this is one of the ones where the CPU has to be still on board. It's not warm or anything like that, and it can switch between the two. So I'm just going to scope pin 15, I'll show you that. Did I say 15? It's 18. I can't count or read, one of the two. So, yeah, hang on, just bear with me a sec. So that's this is without the card in, so this is the normal reset signal. Low and high. Yeah, and that's working. So if I plug the card back in, and we just scope that same thing, I'm guessing it's not going to come out of reset. Right, so we're on the reset pin, switch it on. Low, look. Low. Low, still low. It's still low. And it's just low. Low forever. Yeah, there's the 5 volts. Bang on 5 volts. So it's not like it's pulling the power rail though, because that was one thought I had in terms of reset. Some of these 2000, some of the other Amigas as well have got like a little Nitsumi voltage thing. It checks the voltage level, and if you're not got 5 volts, it won't send the reset pulse. But we do have a good voltage level there, so I don't know. So I've checked the same things we checked last time, and obviously you come to the same conclusion that something on this board is not allowing it to come out of reset. And as I say, I can, I'll just put the wrist strap on a sec, hang on. And as I say, if I feel around, CPU stone cold, it's like it's not even getting a clock. I could scope that, but I don't think it's getting a clock. Or if it's held in reset, it's not going to be doing anything, is it? That's the thing. So yeah, some of the 7.4 series stuff is warm, but I swapped nearly all of the little ones down here. But that gal there, or PAL rather, is lukewarm, but everything else is cold, really, or just really, really lukewarm. That's like the hottest thing on the board. The Mac is stone cold. These chips here, yeah, they are warm. So that's warm, and those are equally warm. So, you could think, well, maybe there's a problem here, but I think this is all RAM related. I don't see how that could stop it coming out of reset at all. So, yeah, the only PAL we haven't swapped out is this one. So I've ordered some of those. I'll show you in a minute. We'll remove that with hot air when they arrive, program one up and swap that out. But it's all guesswork here, because now we know that's the only one that's not been swapped. I can trace the reset signal from here to that cart slot, as I've done before, actually, previously, and then trace it from here to around there. So does it go there? But I don't think it does. I think it goes to the Mac, which is why right from the start I was like, well, it could be the gals, the PALs, because they're getting hot, but I actually think it's the Mac. So just refreshing myself on this, I've done all the connectivity testing again. I marked this with red marks previously. I think they all came off with IPA when I cleaned up at various points when we swapped out some of the 7.4 stuff around here. So just to reiterate, the via here, yeah, that goes to that pin on the other side is the reset. So it comes up through that via, yeah, and it goes to a number of places. It comes into this 04 here, into one of the pins up here somewhere, and then it's an inverter obviously, and the output then comes into the input of this gate on the other side of the chip, and it comes out on the end pin here, and that goes to a pin on the Mac somewhere down here. I forget exactly where, maybe that one actually. I've marked with the red line there, you can see that. So that's the input, but then it also outputs, and it comes out this 05, and the input to the 05 comes from a pin up here, marked again in red there on the Mac. So the Mac is capable of using this open collector inverter here, setting, pulling the signal low, reset, so it can induce its own reset, presumably to get timing and stuff correct so that it can release when it's ready, but perhaps also to swap over to the 68K. I think this supports that feature just like the Commodore one does, and that would make sense that you can get your clocks and things all lined up and everything, and then release, and take certain parts of this off the bus and then release, and your 68,000 works. So that's how it works. Output on this one, input on that one. Those aren't the issues. So yeah, they go to this. So then I was hoping to see a connection to this gal, the one we haven't replaced, but there isn't one. But what there is, or what there are connections from this to this, actually. And the fact this gets warm, and that's stone cold, makes me wonder if some main clocking signal is coming through this, and it's never actually even reaching the Mac. Because you'd expect some temperature there, but there's just nothing. It's like stone cold the whole time. Everything else, including that, is warm. So I think it could be this. I sort of got my fingers crossed. I checked the balked connections up there again, and even though I can't really be 100% certain, I think they're alright. I think they're okay. The 3 that I managed to just expose a little bit, I tested connectivity from one side to the other, they seem alright. So it's either that or that, but why would this be stone cold? Suspiciously stone cold. Yeah, this is stone cold because obviously I think this is not enabling everything. It's not, maybe the clocks are not passing through anywhere anyway, but what else can it be really? It can't really be anything else, because I think from memory, I think I swapped all of this stuff around here pretty much. It's just these that happen, but you see this is like data bus side stuff for the RAM. It wouldn't be just held in reset constantly if there was an issue there, I am sure. And as you can see, it's got a brand new set of gals here, yeah? One thing I did notice is that one's dash 15. We've got dash 10, dash 10, dash 10. These are all dash 15s, I think. That one's a dash 15. So yeah, we've got a bit of mismatch there, but these chips are good. They're programmed alright, they're verified alright. So yeah, let's just wait for that, and I'll report back in a minute when it arrives. Yeah, and thinking about this while I'm waiting, why not get that off? Because I don't see any other options. I don't honestly see any other options. I can scope, and I might end up doing that, just scoping, blooming everything. Why is that not coming out of there? Yeah, I can end up scoping just everything on the blooming board in the hope that I see something weird, but if I see a low somewhere on a gal or something, I'm not going to have any clues there. It may well be supposed to be low. You know, this is the problem when you don't have schematics for a board like this. Flux is right at the bottom now. Anyway, we've got some flux there. Let's get that off. Now, I'll probably need to order a socket. I'll do that actually in a minute. I've ordered the chip, I just didn't think of the socket. And I could solder the new one straight on, but it would be far easier if we had a socket there. There we go, it's starting to come up. I'm not levering here, by the way, I'm just literally pressing slightly upwards. There we go. And then when it's ready, it will come off, as you can see. Anyway, let's get that on. So I'm going to cut the base out. One way you could do this is to heat from the underside, because there's a little under there apart from that label. So you could set up where you've got the hot air on the underside here, a little bit of solder paste or something there, or even just solder, pre-tin them all, line your socket up, heat from the underside, move around until it sucks itself into position. You could do that, but I'm not really geared up to do that, to get underboard heating that way. And of course, if you heat too much, this fiberglass PCB, it may delaminate. So yeah, I think we'll cut the base out. I may need to just trim the tips of the pins down as well, because when I put that over there, it's one of these sockets where the pad layout means that you've got your pad like that, and then you've got your pin, and the pin sits perfectly on top of it. There's not, I need to maybe trim it back a bit so that there's a bit you can solder, onto the pad. I've got lots of these sockets. If I mess this up, well, 10. So let's just try and get in with the cutters maybe. Hang on. Is that broken? Sometimes you can just literally push these out and they'll break. I'll tell you what, let's do it nearer to the top there. Did that cut? It's pretty sturdy stuff actually. It's a pretty sturdy socket, that. These sockets are usually made of the cheapest plastic. This one isn't. Because I can just trim the base off there. Wow, that's not cut. That's an incredibly strong socket. So I did trim the pins back, cut the base out, got the socket in position, held it down, soldered at one point there, one point here in the middle, one point there in the middle, one point there in the middle as I press it down on each side. So it's nice and flat, well, as flat as it can be. It kind of floats off the board a little bit, this type of socket, I don't know why. The other ones didn't, fitted onto the boards. Like when I did the A3640 build, that was not like that. These are different sockets. So yeah, just got some flux on that side, and then I'll try and show you a little bit of this. You're not going to be able to see it because I can't get close enough, and I need to use magnification. But yeah, nevertheless, it's going to be a case of getting some solder on the tip and bobbing into some of these pins here like that. It's 2, 3, 4, 5, 6. Yeah, so anyway, I'll need to use magnification, as I say. Right, that's the socket all soldered on. If you want to see more examples of how to do something like that, check out the A3640 video above. So yeah, I'm just going to clean with cotton bud first of all here, and then I've got the toothbrush. The problem is here, the flux just gets all up the pins, gets under the pins, gets everywhere. So yeah, it's important to clean pretty thoroughly with these. I mean, technically I might be able to just get that end there into the ultrasonic cleaner, but anyway, we'll think about that later. Right now I just want to just give it a brush with the toothbrush here, just leak some IPA all around and inside. It's wiping off my little red marks I put on the board though for the reset things. Anyway, I can redo that if I need to. I mean, this is the last ditch thing anyway. If this doesn't work, I honestly think it's game over for this board, because I'd need a new Mac chip. So I don't know, I don't feel positive. I don't think this is going to fix it. I think we've just got to rule it out. It may be a fail. We seldom get fails where I just like give up. I mean, technically I will never give up. Hence why we're revisiting this, you know, I don't know, a year and a half or something after I first started working on it. I hadn't given up on it. So yeah, technically I probably won't give up on it. Maybe at some point someone will get code for the Mac, but I don't think so. That's quite a really difficult thing to achieve. Someone will perhaps have to reverse engineer it and build some new code for the Mac. So a couple of months later, I got this board from Sparks UK. It came from Stefan originally. Now, my understanding is Stefan was trying to help me out, and he took this gal off here to try and dump it. And when he put it back on, it died. So I'm not sure if he killed the gal or it was about the solid point. I don't think so. I inspected around that. It looked pretty good to me. Anyway, you can see I've removed the gal. The reason being, this board of Sparks, we're trying to diagnose this, it gives a green screen. So the first thing I did is just remove one at a time each of these pals here. Yeah, and swap them for the ones on my board, one at a time. And the behaviour is the same, always gives a green or red screen, mostly a green screen on my 2000 here, and I think that's one of the symptoms that Sparks said it was doing. At some point he managed to get it so it wasn't given a green screen. The crystal socket here is loose as anything, by the way, so I put the crystal that was on the other card and it works okay with that. So the one that came with it has got a bit of Captain Tape here on the table. It needs the you know, the legs adding a bit of solder to thicken the legs up slightly. But anyway, so we've ruled out all of these behave exactly the same on here, which means on my board those are not the problem, which is what I suspected, because I programmed up using the JEDs there, these you know, the replacement code using modern gals. I also swapped the ROM here, exactly the same behaviour, which means on Sparks' board the green screen, I'm thinking it could be RAM to be honest, but it could be some supporting logic around that. It could be this because there was an issue after that was taken off. So anyway, I've tried this chip on my board. Mine's still not coming out of reset. Yeah, well, I said mine, I mean the one from Tom. Ultimately I'll offer it back to Tom if I can get it working. Yeah, so it's the other board is not coming out of reset still. So I still think it's going to be that on the other board, but it could still be some 7.4 series on that board as well. Anyway, on this one now, I'm just going to clean up here, get a socket on. We'll try the gal from the other board, see if that then gets this board up and running. If we get the green screen removed from this and then it boots and the RAM's alright and everything, that's really good, because I can then start to compare this board to the broken board, if that makes sense. I mean, this is technically a broken board, but at least this is actually coming out of reset and given a green screen. I've shown all this stuff so many times before. Yeah, used a bit of braid there, cleaned up with IPA. As you can see, we're now ready for the socket. Alright, that's the socket on there. It's fairly clean. I may just reflow it at some point. So, yeah, I've got to try and remember which way around these are now. So yeah, this is the gal from the other board, I think. If we find the one that's on mine, yeah, there's a bit of sticky on that because I pulled the label off it. So that's the original one. So we'll try the one. I keep saying mine. Technically it is, Tom gave it me, but it's the one from Tom. So let's get the one from Tom into the socket here. And bless you, bet, it's going to make a difference. I think it could do, because this, I think, was the thing that was wrong with this card. You know, Stefan took it off, and then it never worked after that. So let's give that a try. At the very least, hopefully we can fix this board for Sparks UK. Right, so powering it on here. It's doing the same thing, look, green screen. So, it kind of looks like it's game over with both of these, doesn't it? Because I think the thing is, that chip, I think, was at some point on this board the wrong way around. And the fact we've got the chip from the other card, and it's exactly the same thing with the green screen. I'm alright, technically something else could have gone wrong with this board as well, as a result of the chip being the wrong way around, but we've got exactly the same behaviour here. So on Sparks UK's board, the one that came from Stefan, it appears to be none of the gals. And it's bad news for this board, because it means that it's none of the gals on this one either. Well, the good news is in the Rev 6 A2000, the board works,
I have ruled out all of the gals, swapped all the gals. These are all my gals actually, Tom's gals from the other card, and it boots up and everything works. But before I got to this point, I was booting from floppy and running test kit, yeah, and there's a RAM fault, I think, if test kit is to be believed, but it's booted there. We've got 68030, 23.4 it says on the speed. It's pretty much almost in par, well, 0.81, hence the 2 megahertz difference there, at a 3000 6803 running at 25 megahertz, which is curious because it's got a 25 megahertz crystal on it, so I don't quite get that. But anyway, it seems to be working. It may crash here, as I say, because there's that memory issue. In fact, let's just have a look at the boards and the memory and all that. Yeah, so we've got 1 meg fast RAM, 1 meg chip RAM. Yeah, that's right, because this 2000's only got a megabyte and it's configured as all chip RAM. But as I say, if we boot test kit, and let's reboot this, it will fail on the RAM there. Right, so it's booting from floppy, memory, test, list and test regions. So if we do the 1 meg fast, you'll see it starts off okay, and then somewhere on these tests it usually fails, and it's usually on the same, I think it's the same bit here, bit 7. Let's try it again. I'm sure one of them appeared over here, which indicates an addressing type problem rather than the data bit issue. Nope, same one. So actually we might be able to resolve this just by replacing the chip there. And we'll be right in thinking it's the chip, I think, because if it was, you know, it's one of the 245's buffering, it would error straight away on the first test there. And it isn't doing. It's passing the first couple of tests, isn't it? Yeah, so it looks like D7, doesn't it? Well, at least that should be an easy fix on Sparks' card. Well, famous last words. And the curious thing is, obviously we're using all my gals, all the gals from Tom's card here, which shows the gals aren't the problem. So it's got to be either the Mac. There you go. So at least we've ruled out that there's no differences between these two sets of gals here, which is good news for this board, I guess, because all of these are good, including that. So it's just a question of, is it this, is it something here, or is this some 7.4 series that's causing this? Well, it's not coming out of reset. I vaguely remember playing around swapping a lot of these chips, because there are chips of the same type. I remember swapping them, seeing no difference in behaviour. But there were chips like this one here, this 04, that I didn't have a spare for. You know what, I'm tempted to actually pull that off there. The reset line goes through that, hence the red mark. I'm tempted to pull that off, pull the one off that one, and see if we can get this up and running, because it'd be amazing if that's all it was. So I traced D7 to this buffer chip here. I think it's one of the corner pins, which goes to this chip. So you can see I've got a bit of Captain tape just to protect there. It's going to add a wee bit of flux around this, not a lot, and get this off. And we'll take the one off the board from Tom, get this board completely up and running, and then I'll continue having a tinker around with yeah, the board from Tom, technically mine, I guess, could call it. You've got SOJ chips on this, and yeah, they can be an absolute pain to not only remove but to solder as well. There isn't a lot of clearance there to get the soldering iron down the side. Might have to remove the one to the left there as well. The Captain tape's going to lift up a bit here. I'm just really just got that on there, just to try and get some of the direct airflow off it and off the chips and sides. But it's not going to. You see, it's just going to keep flipping up like that. And the main thing is to protect the SIMs there. Or the SIM sockets. They're not standard SIM pin out, by the way, on these. It's bespoke to this. GVP produced their own custom SIMs, which was nice of them. I think it's coming up. Is it? Yeah, I can feel. There you go, it's moving. There we go, pads are intact. So I'll do exactly the same thing on the donor board. I'll take one of the edge ones on the donor board because it's just a bit easier then, isn't it? We'll let that cool a little bit, get the solder off there. I mean, I could, thinking about it, I could actually just fit it with hot air. Might do that actually. So of course we don't know the state of the chips on this one because this board is not booting at all. I've just reused the Kapton tape here and protected the SIM sockets again. And yeah, let's just go at this second time on the other board and try and get this off. It's interesting that it's totally different PCB designs here. I mean, this is a V3, the other one's a V4. But what I mean is, look at the PCB. It's like a almost transparent sort of brown sort of colour. It's like, I don't know, it's made with different type of fiberglass or different, I don't know, something's different about it. Alright, so doing this a completely different way. Where's the chip gone? It's down there. Yeah, I've just added some more solder to each of the pads there, made sure they're levelled off. I stuck some flux there as well. And yeah, I am literally just going to sit the chip over there and try and heat with hot air and wait to see if it pulls itself into almost position. Obviously the key here is making sure it is as aligned as you can get it before the start, like that. Yeah, just use hot air, so let's give that a try. And then I need to monitor this, and then I'm trying to monitor it from the side here just to see if it sinks itself down. It's pretty much there with regards to the pads. If we get this to the right temperature, it should just shift slightly to the left, because it's ever so slightly more over to the right at the moment. I'm tempted to, you know, just give it a tiny touch. In fact, that's secured itself already. This is the problem. You know, one or two of the pins there have sunk the heat. There we go. Right, that looks straight. So let's give it one final flow. That dog is annoying me. Right, I think that'll do. I think that's as straight as that's going to get. Right, connected up. It's all cooled down for a few minutes there. Let's give that a try. I'll point you at this as I switch it on, just so you can see if anything goes up in flames. But just feeling there, it's just lukewarm around there now, so I'm comfortable, I think, switching that on at this stage. Need to just make sure there's nothing on the board to short here. And as usual, there are one or two things here. Right, let's try that. So I've got AV, sitting the IDE, so it is booting, and test kit is up, memory, so it's detecting 1 meg. Let's do fast. Please get past that error. Hey, it's fixed. There we go. So we targeted the right chip, and I'll show you how it worked out which chip it was. It's simple stuff though, but anyway, I am relieved, because you never know, sometimes you can doubt yourself. So yeah, that's the first time since we've got this board in this machine here, you know, up and running, where there's been no RAM errors at all. So that one's fixed for Sparks UK, I think. That is until I break it, because obviously I've asked Sparks if I can just take 1 or 2 chips off the 74 series to try and help rule them out on the other board, although on the other board I do think it's actually the Mac chip that's at fault. Anyway, more on that in a minute. So I'm just scoping around this actually, and I didn't have this scope back when I started on this video, and it was really inconvenient for me to get my scope out, and I didn't have a desk like this, a bench, so it was really hard to scope something like this. I'll show you in a minute why, because I've got to do this side on, be crouched down, and it's near impossible to see what I'm actually scoping. But just look at this signal here, hang on, let's see if I can find it. Yeah, so I've got a signal there, that looks alright. Voltage max 3 volts, 7 point something megahertz there, and I'm starting to wonder if these are used to switch between clocks or something. I don't know, could be wrong. In fact, it's not showing me what I saw a minute ago now. Yeah, what I saw a minute ago was 2 volts on one of these. Let me just probe the next chip here. Yeah, see that? Yeah, look at that pin there. 2 volts, and it's bobbing up and down. This is one of the pins that goes to this 151. That one there looks alright. The end one, again, looks alright. But the one next to it looks like that. So, that could be a problem. Because if one of the clocks is not getting through somewhere, that would explain it not coming out of reset. It ain't going to do much without a specific clock going to a certain pin somewhere. So I think I'm going to swap that 151. I've pretty much exhausted everything with this, and then I got an idea. Connect the logic probe up with a clip. I'm not sure you can see that. Yeah, you probably just about can. I've just rotate it that way slightly. We'll just power it on, and that's the reset. Look, flashing. Yeah, I'm not sure if you can see that flashing. Hang on, it's stable now. Just watch. See this chip, see it flash? Yeah, it's flashing. Yeah, when this warms up. So, it is this chip. It's this chip that's faulty. But I mean, I've literally replaced almost everything on there to rule it out. And you can just leave it there and it'll flicker. It's not doing it now. But it reset then. I'm not sure you can see that. If I hold it, you're going to think I'm wobbling it. But trust me, you're getting a reset pulse. It's just occasionally going, right, I'm going to reset, and it gives up. So yeah, there's some issue with the IC. I think what I'm going to do is just heat it 400 degrees. Obviously not like this. Switch it off. Take the board out. I'm going to heat it up. Now it's being reflowed. I think that's one of the early things I did actually when we spotted this reset problem. Anyway, I'm going to get this nice and hot, and just see if a reflow makes any difference. Yeah, I'm literally just going to go around it like this. I'm not going to cap to tape off here because I'm literally going to heat the chip up. Get it really, 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 really hot. Let it cool down and try it. So testing Sparks' card now with a SCSI, you can see it's booting there. You need to set obviously a number of jumpers. J9 was open, that disables the SCSI, so I had to close that. J14 sets that there's a SCSI drive attached, so that was enabled as well. And J8 toggles between the SCSI ROM and the Octo something ROM. So at the moment I think it's on the SCSI one. I'm not sure if GVP deliberately built in 2 different ROMs there for the SCSI. They must have done, otherwise that jumper wouldn't make any sense. Unless you need, I don't know, some sort of mod that fits to go along with that jumper. But anyway, you can see that as booted. This boot here is expecting the real-time clock and sensors thing from Amiga kit that's not connected. So anyway, I need to connect a mouse. I'll test some games out on it. What I will need to do is add some additional RAM, because the RAM that's provided with this, you've got 1 meg of local 32-bit fast RAM. It's not enough. You can't load anything WHD related with just 1 additional megabyte really on something like this. You need to add maybe 4 or 8 meg. So I fitted Live2's 8 meg gotta go fast card. Going to be interested to see if that clashes with the 1 meg on here, or is it intelligent enough to put this in a different range or something, I don't know. Yeah, it's hitting the SCSI, so it seems to be booting. I would imagine that the memory on the GVP here is going to be mapped into the Zorro 3 range, effectively, somewhere in the 32-bit stuff above Zorro 2. So we should have 9 meg of other RAM now, I think. I've not got a keyboard connected, which is going to be a problem, but anyway, it's booted. And it was pretty snappy actually with that additional RAM. Yeah, it must be enabled in 4 meg mode at the moment because we've got 5 meg there. So let me just power cycle that with the jumper set properly. And in actual fact, it was set to 8 meg, I think. So it must be clashing. It's disabled. I think the Zorro 2 stuff has kicked in, the auto config and gone, hang on a minute, you've got some memory here on the GVP. It can't accommodate 8 meg. So I think 4 meg from the Lift 2 board is the most we're going to get alongside this GVP as things stand. Let's just go into sysinfo. Let's just see what it reports there. Memory. Yeah, so we've got 1 meg fast RAM with priority 10, 4 meg fast RAM priority 0, 1 meg chip RAM. Yeah, and that's the thing. If you look at the range, if you look at where this RAM sits here, that is in the Zorro 2 range, isn't it? Now you can probably change that because there's a jumper on the GVP. But then you may need to do add RAM to add it or something like that. Although on Kickstart and 3.1 and Workbench 3.1 you may find it automatically adds it. I could just try changing that jumper. I might try that in a minute. Anyway, the main thing is just to make sure games and things work with this now from the SCSI. Now the interesting thing is now we've got some additional RAM. This is actually clocking in faster. If you looked at the benchmarks earlier, and obviously it's the way this SCSI card is set up, probably it's using MMU libs and stuff, and it's got burst mode and the various other switches and things set there. You know, CPU parameters, cache enabled, etc. 1.02, before that was coming up something like 0.9, was it, or something, or 0.8 something, which made me wonder. I was like, well, it's 25 megahertz, why is it slower than an 030? Yeah, so you can disregard the previous benchmark there. The performance there is more accurate, I think, 1.02, so it's slightly faster than an Amiga 3000, you know, with its default, you know, 68030 running at 25 megahertz. And obviously this has got an MMU, we've got an FPU, so yeah, very, very pleased. I think Sparks will be pleased as well. Let's just test the drive speeds here on the SCSI. Now it's using the SCSI to SD. There'll be a link up there to the repair of the SCSI to SD. I covered that previously on my channel. Thankfully it was a simple repair. Yeah, so 1 meg, just over 1 meg, that's about right for this. It's a Rev 5.1 I think I've got. The later revisions, as I mentioned in a number of videos, they go a lot faster. You can get like 2 meg or so on the later revisions. But anyway, that's working, so let's just test some games out on it. Yeah, so that's working fine, but can you hear the sound hiccups? Yeah, that's exactly the same problem I saw on another GVP card, which we'll see in another video. Yeah, the throughput, even though it's reported about a meg per second, it's a wee bit slow without the GVP drivers and things, and I think this is the thing, you probably need to install a driver. Could be wrong, but yeah, you'll see in the other video, this is exactly the same as my other GVP card, and it's not the, you know, not the same model, it's just a SCSI and RAM board, that one actually. But it's doing exactly the same thing where the sound on this breaks up a little bit, which shows the throughput, strangely enough, isn't as good as my A2091, but I put that down to drivers. And incidentally, we're using Live 2's Bluster there, so yeah, it works fine with the GVP. You know, the arbitration that this controls, if you like, is perfect with Live 2's card, the GVP, and the IDE board, you know, the 80 bus card that you saw me testing earlier. We're booting that, using that for the IDE. So yeah, it's just an extended bit of testing really on the Bluster. Continue to use that on everything that comes my way, and it's rock solid. Just testing a bit of the new game Devil's Temple here. Fantastic game, it really is. And look at the attention to detail. I like the little posters and things in the back of this level here. I think we're at the cinema or something, aren't we? Look at that Cobra, Jaws, brilliant. Absolutely brilliant. Oh, I'm so bad at this. Those guys, you've got to just jump through them. Yeah, so working completely normally here. The SCSI's working fine. Let's just try a bit of Gauntlet, another game on the Amiga you probably don't know exists. It's an ST port, this one. Sweet. I'm not sure, but it may lack samples, I think. Yeah, I connected the keyboard up and then just hit space. Hang on. I'm not sure how you start this. Return. Oh yeah. So yeah, it's a port of the ST version. But you know what? It's pretty good. It runs a bit better than the ST version, I think. It does have the samples and things. Well, some of them. Let's just see if it's got any of the samples. No. It would have been nice if they've added some samples in from the arcade maybe. So I've been testing this for hours, no problems at all. Let's just switch that off. The crystal here tinned up legs with a little bit of solder, and then it makes a really snug fit. But then just to secure it, I've put a cable tie around there. You can't move that crystal, you know, you need to cut the cable tie to pull it out. So that just makes it reliable. The green screen issue, not sure I mentioned that I worked out what that is. It was a dirty pin on the CPU. I'll take this out in a minute because I'm going to clean up the pins on it, but I just used some light sandpaper on the legs there, plugged it back in, and the problem went away. But it was definitely that. So that explains when we tested it on the first board, the Rev 4, why it wouldn't boot, and it was given as a green screen. And in fact, then when we transplanted it here, it gave me a green screen as well. And only after reseating a few times, messing around with the panels and things, suddenly the green screen issue went away at some point. And I just assumed it was a bad connection somewhere, but what I didn't realise, it was a bad connection on the CPU. And obviously we need to get the can back on here, but beyond that, this card can go back to Sparks UK, I think. So it's looking very clean after doing all the work. I swapped these chips and that one and these two between the boards, just to rule them out, because I think they're the only chips that are not ruled out, actually. I scoped the heck out of that other board. I can't work out what's wrong with it, but you've seen, well, I say I can't work out what's wrong with it, you've seen that the Mac chip on the other one is temperature sensitive. You just put a bit of heat there, suddenly the reset starts flickering, just with a bit of heat here. I will experiment a bit more. I did consider maybe I should have taken the chip off, but you know what, the solder points all around it look fine. So I'm darn sure the problem on the other one is the Mac chip. It can't be anything else. The only thing we didn't rule out on the other board, and I'll show you in a minute, is the 245s. Yeah, there's like a bunch of them here, there's two here, and there's two here. These for the ROM, just to gate access to the ROM, I think, could be wrong. These are for the RAM. So if there was a problem here, you'd have a data bus problem. It wouldn't not come out of reset. And the two here, I think, are either for the expansion here, or it could be to get access to the FPU. I don't know, but in any case, I think we exhausted all options in this video. At least we've come out with one out of two working. Yes, the other one's now missing one of its RAMs, you know, because it donated it to this, but we can easily backfill that if I could work out what was wrong with the other one, or, get a Mac basically programmed up on the other one. I did consider looking at ways to dumping this, and I might dump the one that's on the other card actually, and send a replacement chip to Sparks for him to test on this. That's probably what I will do. I spoke to a few people. Liv2 suggested dumping it as an EEPROM. That's one way of doing it. So on your inputs, the input pins there, typically on these types of GAL, one side's like inputs, one side's like outputs. So on the input side, you connect your address lines effectively, and on the output side, you connect your data bus, and then you could, you have a combination of all the addresses and get all your data back, which effectively is can give you an insight into the logic. And I spoke to Furtek actually to see if he had anything set up, to do that, because I talked about doing that myself before with an Arduino or something. I could do that, and there's projects out there that do the same thing, but the whole point is you can dump it as an EEPROM in something like a TL866 that way, and then use a little bit of software that someone's written that will analyse the what's been read back there, the ones and zeros basically, and give you the logic for it, and you can then program up a new chip. So I might have a go at that in a future video. That will be a follow-up, and I might need Sparks' assistance if I program up a new chip, send it out to him and just say, can you just remove this carefully with a screwdriver and just test the replacement chip. If that's the case, that means we've got dumps for all of these logic chips here, these PALs. They're actually PALs originally. We need to also wipe off these red marks. I marked the ones on Sparks' card here with red dots before I swapped them all around, so those can be wiped off now. They're all good. It's got all his original chips on here, and obviously I stuck that label back on with a little bit of glue. So I got the shield back on, wiped all the marks back off, and got the bracket back on, which is held by one screw right at the back there. So just giving it one final test, just because he's not connected at the moment. Trying to make sure it's still booting okay, and then that will wing its way back to Barry. Now it's taken quite a while to boot because the jumpers are set to look for the SCSI drive. There's probably I don't know, a 30-second, 60-second timeout or something looking for that, probably. So we'll just give that a little bit longer, I think. I hope that's working. Yeah, there we go. So yeah, it looks a bit dark on the screen with the light in here, but that's working fine. On Super Macro, I'm not sure if you can see, if you look in the middle of the pins where it's able to focus, they look like really dark. Some sides more than others. Yeah, it's incredibly hard to get this to focus with the lighting the way it is in here. But yeah, they just need to clean up, so I think I'm just going to squash a cotton bud and get some deoxit and just go in between these pins, actually. And I know I mentioned with annotations earlier on about how I worked out which RAM chip it was on Barry's board there. But what I did is I looked at the pin out for the 030 here, found D7, took the chip out, continuity test on D7, and then went around these 245s here, went beep, found a beep somewhere. As soon as I found which chip it was, yeah, it's just a case of look at the pin out of this, and you'll find that the pins go sort of slightly diagonal by one pin, you know, so that you've got a side and a B side, and the side that was on, let's say it was the B side, for example, I'd be trying to find its opposing pin on the A side. So if I was on B3, for example, I'd be looking for A3 here, and then continuity test from there to the RAMs, you know, because each one of these RAMs is 4 bits each. Yeah, so each of the individual data bits, 4 of them go to each separate chip here. And I think the difference between these SIMs, and you can buy these off eBay, by the way, if you want a SIM for one of these, they're pretty cheap, 20 or 30 quid each, I think, roughly, which sounds like a lot, but the brand new ones, yeah, if you want those, you can get them on eBay. I think they're a pin short or something. I think GVP, you know, just shrunk it by 1 pin or something like that. So yeah, you can't just put standard SIMs in there. And as a final point here, if you've got one of these cards and you're thinking of clocking up to 50, I would suggest don't do that, because that's what happened to this card. Apparently it'd been run really hard at 50 megahertz for a period of time, and then it just died. And I think we kind of proved towards the end there, heating with hot air, 150 degrees here, just for a few seconds, bang, suddenly you see the reset starting to pulse on its own. And there's no flowing connections, there's no bad solder points, and everything on it here has been pretty much ruled out. The only thing I didn't do is take off all the 245s. I mean, I could do that. Post your comments down below. Do you think that's a good idea? Do you think maybe there's some sort of control signal going through one of these somewhere? Maybe a few of these are used for address lines. That's something I haven't actually stopped to think about. That maybe the reason it's not coming out of reset is because it doesn't see a reset vector or something somewhere that maybe gets set on the Gary side of things or something like that. I don't know. I think it's the CPU that sets the reset vector though, so I don't know. Anyway, post your thoughts down below. Trying to reverse engineer something like this, as I say, is very difficult. I described before what you can do with PALs, you know, the ones that are just combinational logic, you know, no registers inside them. But with something like that, it's going to have registers in there. You know, you've got things like flip-flops and stuff in there. So trying to reverse engineer that is pretty hard without, you know, just doing a full logic capture of everything there and trying to reverse engineer something like this. And I don't think that's ever going to happen. It's a shame that the guys at GVP didn't push the JED files and things, you know, the equations for these devices into the public domain, because it's just kind of like history that's lost, isn't it? One by one, these GVP cards are going to all die out, and then that'll be it. You'll have to replace with a terrible Fireboard, which you're going to get better performance with anyway, really. It's just a nice card, because I like the SCSI, you know, has it got SCSI 2 or something on these? I don't know, but anyway, the SCSI's supposed to be pretty fast once you get the right driver installed. So I do hope you enjoyed the video. Thank you ever so much to Sparks UK and Tom for sending this card as well. I'll just give you a quick look. Actually, you can see, just noticed I've got 2 RAMs missing off this. Oh yeah, I know why. Yeah, we did the FMV module, didn't we, with the CD32, and I borrowed one of the RAMs off that, and the RAM is actually taped on the back somewhere. There it is. Yeah, and you can see, yeah, and you can just about see blurry there. That's where I fixed that trace. And on the other side, I scraped the surface off there to inspect, and the connections were okay. But anyway, yeah, huge thanks to Tom, and thanks to Sparks UK for sending it, and also to Stefan, because you know what, the reason we were fixing Sparks's card is because that was the only gal that had not been dumped. And Stefan kindly, off his own back, didn't even ask me, said, Chris, I've tried to dump it, I've took it off mine and I can't read it, so it must be protected. So yeah, thanks ever so much for doing that, Stefan. And ultimately that's why you then passed it on to Barry, and then I, you know, fixed it. So yeah, you didn't do any damage when you got that chip round the wrong way, Stefan. It was just about the RAM. Anyway, thanks for watching. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.